here. This is section 1.2. This is section 1.2, and we're being recorded now. So what I did was I want to do a few examples, but first I want to just bring up, and this is just a page that I photocopied from the textbook, what echelon form is, what reduced echelon form is. So echelon form has these three requirements. Okay, these three requirements. And basically that's like getting the matrix in triangular form, which we talked about last time. That's called echelon or row echelon form. But if we then do doing the forward phase of the row reduction to produce zeros in the bottom left-hand corner, to create that triangle of zeros on the bottom left-hand corner of the matrix, that's the forward phase of the row row operations that you're doing. Let me just see here. Hold on. One moment. That's the forward phase of solving the system. But then to do the backward phase, where you get the system even in simpler forms, that involves getting the augmented matrix in reduced echelon form, and that involves steps 4 and 5. And you've seen these steps. When we did that first example where we solved the system doing the row operations, we actually talked about we actually did all of these 5 steps. Now sometimes what happens is it can be a little abstract, remembering definitions and things like that. I find it very helpful in order to understand the concepts in the course. Examples are tremendously helpful. So what they have here is they give this definition in 1.2 of echelon form and reduced echelon form. Okay, and then they have an example here. Okay, so actually look here. Here, a little bit below, okay, this first matrix here is in echelon form. The first matrix is in echelon form. Okay. Now why? So for instance, all non-zero rows are above any rows of all zeros. That's satisfied. Secondly, each leading entry of a row in a column, each leading entry of a row is in a column to the right of the leading entry of the row above it. That's true, looking at the matrix. And well, when I scan this, so what you can do, this is like the best I could do. Now, one thing I'm going to look at over this weekend is bringing up the ebook. But I tried that and it didn't work too well. But we can zoom in. And by the way, you can zoom in too. I can zoom in, but you can zoom in also on your Blackboard. Okay. Thank you, Mikkel. Is it Control Scroll? Okay. Is that a little better? Is that a little better? All right, so, okay, great. Wonderful, wonderful. Okay, so the reason I like photocopying the pages sometimes is because, Divahar, that would be great if you could do that. I'm sure I can get one, but that would be great. Thank you. The reason I like photocopying the pages in the book is because then I can use the pen to write on things, to write like on the example. But are we okay with this matrix here on the left being in echelon form and that it satisfies these first 3 conditions? All right, Christy's good. And actually, this was the augmented matrix that we worked through in the last class. Excellent. Thank you. Thank you, everybody. Well, now to get it, the thing is, you see, the echelon form of a matrix, then, we can break it down further and get it in reduced echelon form. Okay? In reduced echelon form. And that's here. And that's just doing the, so the first matrix here in echelon form is the forward phase of the row operations. And that's because we get zeros produced in the bottom left-hand corner. That's how I like to think of it. Okay. But the matrix on the right, we did a forward phase to get zeros on the bottom left-hand corner, and then we did a backward phase to get zeros on the top right corner, so to speak. That's how I like to think of it. I don't, that's how I like to think of it. And we use the ones as pivots to produce zeros in the columns. Okay, you notice the leading entry in each non-zero row is 1 in this matrix to the right. That's true. And then each leading one is the only non-zero entry in its column. And that's true too. This, again, this matrix on the right corresponds to the matrix that we did in the last class. Are there any questions on this? Always think of examples to help you feel comfortable with the concepts. Now, what they have in example 1 here, and you're going to see this in your homework, is in example 1, let's see, the leading entry, hold on here, the leading entry is the first non-zero number in the row. That's what the leading entry is, the first non-zero number in the row. I don't know about elementary matrix. I'm not worried about elementary matrix right now. There are things we are gonna see elementary matrices later. Oh, no problem, Binyam. We are gonna see elementary matrices actually later, but and I apologize if I misspoke the word. The left matrix is in echelon form. The right matrix is in reduced echelon form. Now, in example 1, they say the following matrices are in echelon form. And what they're doing is the boxed entries have non-zero values. The starred entries have any value. Okay, so the first 2 matrices are in echelon form, and then the next 2 matrices are in reduced echelon form. So you see, what's going to happen is you're going to have like multiple choice exercises where you have to identify which matrices are in echelon form and which are in reduced echelon form. And they're a little bit abstract. They don't put numbers in, but I'm just saying that the boxes mean non-zero values and the stars can have any value. So I'm just bringing this to your attention because I want you to be aware of that. Okay. Now, any matrix that's in reduced echelon form is unique. Okay, it's unique. In other words, if I were to say on the first exam, take a matrix and put it in reduced echelon form, everybody would have the same exact matrix. Echelon form, on the other hand, and that's the form where you just satisfy the first 3 conditions, that's not going to be unique. People could have different answers and still satisfy the echelon form. This is why we like to generally try to get the matrix in reduced echelon form, because it's then unique and everybody has the same matrix. Okay, so that's just a little just background on that. What I'd like to do now is I'd like to get to one of our examples here. Okay, so, and the examples that I do, sometimes they're ones from the book, sometimes they're different ones. It just depends. I like to be sure you have a variety. But let me give you a moment to copy this example down in your notes. Okay, take a moment here. All right, so and I try to pace myself carefully in the lessons because I know that many of you are copying down the examples, which is good because writing is thinking, right? Writing is thinking. Okay, so now this is an augmented matrix, and we understand that these numbers to the right, well, first of all, how many equations are we talking about here in this linear system? Excellent. 3 equations. And it's augmented. So we know that to the right of the equals on the first equation is a -4. Second equation to the right of the equals is a 3. Third equation to the right is a 7. All right. To the left here, these are all coefficients of your variables. How many variables are there in this system? Excellent, 5. All right, and I see that you're doing the homework, by the way. I saw a lot of nice scores on the homework. How many missed a multiple choice, by the way? Did anybody? It happens. I know. Okay, all right. Thank you, Francesca, for your honesty. Thank you, Vivian, Christy. Appreciate it. Yeah, nobody's perfect, right? But all right. So, but those multiple choices, you really do, you know, I mean, you know, you're probably learning those you really got to take your time on. Okay, so is this system in reduced echelon form? Okay. Is it in, now I didn't say echelon form, I said reduced echelon form. Yeah, it's not good. It's not in reduced echelon form. Because for instance, look at this one here. What do we call that one? That's right, Christy. It's a pivot. Thank you, everybody. Bethlehem, Kazab, Diva Heart. It's a pivot. If the matrix is in reduced echelon form, then we use the pivot to produce what values in these, hold on here, what values in these two spots here. What values have to be there? Zeros. That's right. That's right. So are there any questions on that? Oh, do you need an equation for every variable? Oh, well, you know what, Mohammed, in linear algebra, we can have more variables than we have equations. Yeah, you're used to, okay, if I have an x and a y variables, I have 2 equations. If I have x, y, and z variables, I have 3 equations. Oh, not linear algebra. Linear algebra, we can do anything we want. So in this case, we have 3 equations. Yeah, excellent question. Excellent question. We have 3 equations with 5 unknowns. Okay. Now, do we know the values of, so let's call our variables, you know, x1, x2, x3, x4, and x5. Okay, hold on, Matthew. Question from Matthew here. Which can you run? Well, I mean, there are 2. The condition that for reduced echelon form is when you have a pivot in one of the columns, you have to have zeros everywhere else in that column. So like the first column is good. That 1 there, we have zeros below it. But this column here is not good because it's we have a 1 there, and we don't have zeros above the 1. A pivot is used to produce zeros in a column through row operations. That's what a pivot is for. A pivot is used to produce zeros in a column, and that's what that's for. And again, for those of you that weren't in the last class, it's going to be very important that you watch the lecture from our Tuesday's class. But that's what's going on. So, okay, well, do x1, x2, x3, x4, x5. Do we know one of the variables? Do we know what one of the variables equals? x5. x5 equals 7. Absolutely. But what about x1, x2, x3, x4? We got to find expressions for those. So why don't we try to get this augmented matrix in reduced echelon form? Okay, it'll make our lives easier. So what we're going to do here, and you've had practice with this, basically we're very happy. We're very happy with the bottom left-hand corner of the matrix. But what we want to do now is use this pivot to produce zeros in, in this spot and this spot. And so let's work it through. All right. And I know I usually try to have my notes neat. I think this is readable enough, but you know. So the matrix, like I said, the matrix is in echelon form. We want it in reduced echelon form before solving for what's called our basic variables. Basic variables. And I'll tell you what those are when we get to the solution. I had page numbers in my notes, but I crossed out the page numbers because sometimes the ebooks, the page numbers there don't correspond with the page numbers in the physical textbook. But we'll get there. So, all right. So I'm going to let you copy a little bit here. All right. And once you get down to this step here, we'll have a little discussion. Okay, so here we are. So notice that, okay, we'll stop it right there. Okay. All right. Okay, so what's going on here? Now we have this pivot here, and we take the third row, okay, let me blow it up a little bit more. We take the third row and multiply it by 1 in our minds, and then add it to the second row, and replace the second row with this result. This is how we denote our row operations. So the reason we multiply the third row by 1 is because, remember, we're basically multiplying the third equation. Well, what we're doing basically is we're adding what we're doing is we're just adding the second equation. Remember, a row in an augmented matrix is an equation. We're adding the third equation to the second equation, and then replacing the second equation with the result. 1 and -1 makes 0. 7 and 3 make 10. And then adding zeros here, adding these zeros to those numbers there doesn't change anything. Then what we need to do is we need to get a 0 here. So again, I'm going to use my pivot in the third row. I'm going to multiply the third equation by 2. Why? Because 2 times 1 is 2, and 2 and -2 make 0. So I'm taking the third equation, multiplying it by 2, and adding it to the first equation. And then that result, I replace the first equation, the first row, with that result. Okay. Are there any questions so far? Okay, is this matrix in reduced echelon form yet? Still no. Why not, Matthew? Who can tell, Binyam, Christy, why not? What's the problem? That's exactly right, Matthew. This 2 here in the second row needs to be what number? Needs to be a 1. Excellent, excellent. I see people are doing their homework here. Needs to be a 1. So what we're going to do is we're going to multiply the second equation by half. That's like dividing by 2, right? We're going to multiply the second equation by a half. Here, we're going to multiply the second equation by a half. And then that'll be the equation that goes in the, we'll replace the second equation with that equation divided by a half. It's just reducing the equation. So now we're down to this step. Are we in reduced echelon form now? What do you think? Yeah, I don't think so yet. We're pretty close, but not quite yet. Mikkel, why don't you think we're in reduced echelon form yet? The two, that's right, Kevin. Thank you. And I'm sure, yeah, Mikkel had the same idea. The 2 in the first row. You see, the 1 is a pivot. And that's right, Benjamin. The 1 isn't the only non-zero. The 1's a pivot. So we're going to have to replace that 2 with a 0. That means we're going to have to multiply the second equation by -2 and add that to the first equation. And that's what we do. And then we replace the first equation with the result. Question? Condition 4, let's see, Matthew says, condition 4, the leading entry in each non-zero row is 1. That's right, but yeah, okay, yeah, that's true. That's true, for it to be in reduced echelon form. And now, I mean, is it a reduced echelon form now? Let me see, row 1. No, okay, I see your question, Matthew. The problem is, since in the third column, since 1 is a pivot, then as Binyam says by condition 5, the leading 1 is the only non-zero entry in its column. So that's right. That's why you don't quite have it in reduced echelon form. All right, excellent. You see how doing the problem reinforces the concepts, the definition. Can we do anything more to simplify the system of this system of equations, or have we gone as far as we can go? Is this in reduced echelon form? This matrix here? That's right, Mikkel. It is. It is. And so now it's time to. Oh, quick question. In order to be in reduced echelon form, let's see. Siad asks, we just need to look for 1 and make the other 0 in the column. Well, yeah, that's your that is critical. That is critical. Yes. That is absolutely critical. All right, you're welcome. Well, now let's go ahead and take this augmented matrix and write out the equations for the augmented matrix. I'd like to move to the next page. Are we okay here? Does everybody have the example copy? Okay. All right. Well, okay, Moshe, what else could we do? What else would you want to do? Anything you do, I mean, you could do something else, but it's gonna then, anything you do, you might make something look easier, but like you could get a 0, like for instance, maybe like you could get a 0 where that 3 is there, but then you're gonna get a non-zero in this spot. There's just no way to break it down more. Excellent. That's right. Binyam's right. Okay. All right, everybody's good? Yeah, you see what I'm saying, Binyam? Yeah, it won't buy you anything, so to speak. Um, okay, well, let's write out the equations. Here's our system now. The matrix is now in reduced echelon form. The way, Moshe, you know when you've hit the end is when the matrix is in reduced echelon form. That's how you know when you're done with your row operations. When the matrix is in reduced echelon form. And this matrix, that matrix is in reduced echelon form. And so now you can write out the system. Very good. Very good questions, everybody. Good questions. This is why class participation is so important, because when you ask a question, there could be 2 or 3 other people thinking the same thing. It's always good to know why. Okay. So we have then, we have the system now, and I've written it out. Well, you know, Matthew, we have the equations here. We can't do any more simplification, so it's time to solve. Now we know that, well, let me ask you, is this system of equations going to have, like, let me ask you this, like, we know that there are 5 variables. So we can't even think about this geometrically, right? Because geometrically, we have to stop at a system with like 3 variables, like planes, right? But do these equations, is the solution to this equation going to be one single point with 5 coordinates? We know, well, we know the last coordinate is 7, right? Because x5 equals 7. The question is, what are these? Well, they're not unique because we have more variables than we do equations. So what we do is we say, okay, let me work backwards here. So normally, like, you're used to solving x, y, and z, like, well, not necessarily, but it's sort of, for students, it's kind of when they first learn to solve a system of equations, they would solve for x and then find y. Okay. But here, it's going to be easier to solve for the x5 and then work down to x1. So x5 is 7. x5, I'll tell you what, let me ask you this. x5 is 7. I think we all agree on that. Do you agree that x3 would have to be equal to 5 plus x times 4? Yeah, based on that second equation, x3 is definitely 5 times x plus 4. Okay, so we've used this third equation. We've taken the information out of the third equation. We've taken the information out of the second equation. And do you agree that the x1, based on the first equation, is going to be equal to negative 6x2 minus 3x4? Yeah, so now we've used all the information in the equations. Okay, those are called our basic variables. Those are called the basic variables. Okay. Now, one moment. The basic variables, though, so I think about this very simply. We know something. We know what x1 is. We know what x3 is. We know what x5 is. Do we know what x4 is? Based on our system of equations, do we know what x4 equals? Can we say what x4 equals? No. Hence, we let it be free. It can be anything. X4 is it's a free variable. Do we know what x2 equals? Do we have any conditions put on x2? No, we don't. It's a free variable. So the basic variables x1, x3, and x5 are written in terms of the free variables. You notice x3 is a function of the free variable x4, and x1 is a function of the free variable x2 and the free variable x4. So there are 3 basic variables and 2 free variables in this problem. Are there any questions on that? Well, let me ask you this. How many solutions are there to this system of equations? How many solutions are there? That's right, Divahar, Vivian, and Binyam, and well, Christy says a lot. I can infinite. Moshe, right, as many as you want. There are infinite solutions. Why? Because we have 3 equations with 5 unknowns. That's another way to think about it. But, so if free variables are present, that's right, Kevin, then there are infinite solutions. That's right. That's correct. Free variable concepts you will see a little bit, Binyam, down the road. I'm gonna keep you in suspense, okay, on that. But you'll see that. You'll see that. Now, what if somebody looks? What if somebody comes along and says, "I think that that 1, 1, 1, 1, and 7 is a solution." Suppose somebody asks you, "Hey, is 1, 1, 1, 1, 7 a solution?" That's right, Moshe. If there are more variables than equations, there will be infinite solutions. That's right. Very good. Is 1, 1, 1, 1, 7 a solution? Why not, Vivian? You're right. That's not a solution. And it's okay to offer, right answers, wrong answers. I welcome answers, okay? You're learning. Divahar says it doesn't meet the basic variable constraints. Well, what's one of the problems? Okay, now Binyam says in the x3, if x3, so in this case here, you're letting x3 equal 1. You're assigning 1 to be equal to x3. Then, let's see. Then x3, well then, and x4 is 1 also, you're in this case. So if x4 equals 1 and x3 equals 1, Is the third equation is the third equation satisfied? No. No. So just because it's a contradiction, so just because you have an infinite number of solutions doesn't mean that, you know, it can be any old solution. The solutions still have to meet the constraints. They still have to meet the constraints of the problem itself. Okay, are there any questions on that before we move on? Okay, Moshe, yep. Okay, good question. So Moshe's saying, do we have to have x2 and x4 be the free variables? You don't. You could, for instance, you could let like two of the other variables be free variables, and then solve the remaining three variables in terms of those variables. However, based on the reduced echelon form that we have here, well, or based on the equations that we have, this is the easiest. This is the easiest solution, right? And x5 equals 7. Right, x5 is just 7. It always has to be 7. Its value is constant, that's right. Well, what I like to do, Moshe, is I like to work backwards. x5 equals 7. You notice how I solve for x5, x3, and x1. Second equation, I let x3 equal, you know, I have a 1x3. Oh, let me solve for x3. I have in the first equation, I have a 1x1. Oh, let me solve for x1. Yeah, you pick what's easiest. That's right, Wastina. And Moshe, yeah, that's right. That's right. Take the first variable. Yeah, that's right. Okay, so this is really what section 1.2 is about. This is really what section 1.2 is about. You know, and again, you know, I try to hit upon the key ideas, but you know, it will sometimes you will need to you know, look at some of the examples in the book as well. But all right, well, let's then move on to the next question or the next section. I'll stop the recording here.